Hello, and welcome to the Module 1 video for Cool Creative Communications, Dazzling Data Visualizations. Let's get started with some theory. In this video, I'll talk about principles of visual design, and hopefully you'll get inspired to start experimenting with visualization. Visualization enables viewers to quickly glean insights from data. Data is everywhere. Structured data is much more rare, and it takes a lot of work to capture and structure data and tease out the objects and attributes and relationships. The table on the left is from census.gov. It shows the percentage of the male population at every age in the year 2017. In a sense, a table like this one is already a graphical representation of data relationships. It's organized so that we can find what we need to answer questions. But it would still take a while to scroll through different years and different ages to find the figure you're looking for, and it would take some time to compare the values and determine trends. On the right, in the graphic, we can quickly see how the population is distributed by sex and age. And on the original site, the graphic is animated, so we can watch that distribution shift over time in a matter of seconds. Math, statistics, and information science give us the tools to organize and analyze data, but visualization enables us to see data in context. Data visualization is essentially the practice of attaching visual attributes to data points to represent data relationships. So this is my own definition that I developed, and it'll serve as the foundation of what we'll talk about in the next few minutes. We represent the data points with visual marks on the page or screen, and we vary these marks in different ways to represent the relationships between them. These are cartographer Jacques Bertin's 7 original visual variables. Bertin was a French cartographer who, in the 1960s, was among the first people to provide a theoretical foundation to data visualization. If you study this field further, you may see other visual variables referenced, but a lot of visualizations boil down to these 7. Position, or changes in location, as on an X or Y axis. Size, like the length of bars on a bar graph, or the size of wedges in a pie chart. Color hue and color value, as you're likely to see on maps. Orientation, or slope. And then, I think, less frequently, shape and texture. Shape and texture may be used when color isn't an option, or when you're trying to represent several variables at once. Let's do a quick exercise. Take a few seconds to figure out how many 3s are on the screen. Try again now. I've manipulated a few visual characteristics, the line weight of the 3s and the color of all the other numbers, and we can instantly see that there are 4. Now we can analyze this image pre-attentively, or without the need for attention, and in milliseconds. When we're designing information visualizations, we leverage the principles of human perception to instantly infuse meaning into data. We as humans are always looking for patterns, form, and structure. So from this idea, there's a set of rules for human perception called the Gestalt principles. There are a handful of these principles, 7 or 8, but for data visualization, we're going to talk about 3 of them, the 3 that I think are the most relevant. These are simplicity, proximity, and similarity. The rule of simplicity is the basic law of Gestalt. Humans have a limited capacity for processing input, so we're always looking for the simplest, most relevant way to interpret what we see. This is the idea of vision optimization. Many of you recognize the IBM logo, and even if you didn't, you'd recognize the letters I, B, and M. This image is really just a collection of shapes, but looking at it, we instantly organize them in a very familiar way. On the right are little electrical outlet faces. You're getting some help from the stickers in that image, but faces are a very familiar form to us, so it's easy for us to find them. The principle of proximity is the idea that objects that are closer to each other are perceived as being more related than the ones that are not positioned near them. Here, rather than just seeing 20 circles, we tend to see two groups, a group of 4 and a group of 16. Proximity is used a lot in web design. One example of this might be buttons on a website navigation menu. They should all be together, usually either along the top of the website or kind of stacked down the left-hand side, because they all have the same function. And finally, the principle of similarity says that if two objects have similar characteristics, we perceive these objects to be more related than the ones that don't share these qualities. So again here we see two groups of circles, a blue group and an orange group. Back to our threes. Here we don't have the principle of proximity. Our threes are all spread out. But there's a dark black group and a light gray group, and they're quickly and easily separated and associated together. We have our threes, and then, even though the rest are all different numbers, we just sort of group them together as the non-threes. Here's an example of a visualization that makes meaningful use of proximity and similarity, and uses hue and position to show the relationships within the data. We have colored dots of the same size and shape, each representing a member of parliament. They're grouped by color, which represents political party, and by proximity, which represents voting behavior. They're also positioned on the page based on how they voted. Closer to the top right corner indicates voting closer to the Tory establishment. Closer to the bottom right indicates voting in alignment with the Tory rebels. I don't know much at all about British politics, but I can see quickly that there are about 10 clusters of blue dots and 2 larger main clusters of red dots. The whole graphic is fan-shaped, with the dots more distributed top to bottom on the Tory side, and more concentrated in the middle on the Labour side. And all of that is confirmed by the title and subtitle. Myriad divisions, and Theresa May struggles to hold together her fractious party. The designers selectively labeled only a handful of the dots with MPs' names, highlighting some specific pieces of information, but not overwhelming us with all of it. When it comes to applying these principles to your own visualizations, here are some quick, practical tips. Be mindful of cultural and symbolic connotations of color. This is a map of the Hampton Roads area and part of northeastern North Carolina, and the map is from September 6th, 2019, which is, I suppose, right before maybe Hurricane Dorian or some other large storm. The colors divide the map into evacuation zones to try and help residents understand what to do. Zone A encompasses the areas that have historically experienced flooding. Zone D encompasses the areas that are at the least risk for flooding. One of my Facebook friends posted this, and there was a lively discussion in the comments about why the Virginia Department of Emergency Management used red to indicate the safest areas that are the least likely to flood. Some of the connotations that I know surrounding the color red are urgency or danger. I think of stop signs, weather radars, exit signs, and fire alarms. Someone suggested that maybe they were trying to follow the color schemes of a topographic elevation map, but for me, when you're talking about emergencies, especially weather-related emergencies, that's not where my mind instinctively goes. Another comment, and this is kind of an aside, but I thought it was odd to use blue as the region color of the land that is closest to the water. I understand maybe a connection between blue and flooding, but as someone who doesn't know this geographic area very well, it's hard to tell what is land and what is water, because the blue for water and the blue for Zone A are right next to each other. The next tip is to get it right in black and white, and be inclusive of people who don't perceive color like you do. This is a big topic that I've tried to condense into one slide, but there are resources online that can help you choose accessible color palettes, and I've included them on the resource page for this module. On this slide, I have featured what I think is a good example of designers getting it right in black and white. I think that the black and white map has sufficient color contrast that I can still see the system of roads, which I believe is probably the most important information on this map. I can read all of the labels, and I can still tell the difference between what is land and what is water, and there's even another shade that shows the land that's part of the national seashore. The next tip is to simplify. The data-ink ratio is a concept introduced by Edward Tufte. It basically asks, is all of the ink on the page representing meaningful data? The applied version of this concept is, design like everything will be printed and you'll be paying for the ink. Does every mark on the screen or page convey important information? If not, consider it carefully. On the slide, I did a little chart makeover. My hypothetical situation is that I wanted to show some increase of something for the School of Medicine. I removed the scale information, imagining that the change over time and the comparison between the School of Medicine and the other schools was the most important information, and exact values are not as important. I could refer viewers to the spreadsheet if they're interested in that. I also used color more strategically to emphasize just the line that I was most interested in. Opinions may vary, and a lot of this comes down to personal judgment, but in this case, a simplified design makes it easier to understand my point. And finally, follow familiar patterns and structure. And this just means that there are certain things that we expect when we're looking at a document. We read from left to right and from top to bottom. We're used to north being at the top of the page, and south being at the bottom of the page. We tend to expect the biggest things to be the most important, and for ideas to be expressed from most general to most specific. These principles manifest in a handful of common, familiar types of charts. As you develop your goals for your visualization, you need to think about what aspects of the dataset you want to highlight. Then you'll need to choose what type of visualization best emphasizes those aspects. There are many people who have put a lot of thought and research into choosing charts, and in fact, in Tableau, the software will suggest chart types for you based on your data. Here's another guide that I liked in particular, by Stephanie Evergreen. The Chart Chooser 3.0 is a useful guide to different types of visualizations organized by goal. Here, the designer used a familiar chart type for showing change over time, but for whatever reason, she inverted the y-axis so that 0 is at the top. One of the expectations that I have as a viewer is that 0 is going to be at the bottom of a y-axis. If you asked me to point out the year with the fewest number of murders committed using firearms in Florida, at a glance, I'd probably tell you the most incorrect year. Whatever her reasoning was for reversing it, in this case, I don't think was a good enough justification for veering away from familiar patterns and structure. Another thought that I have about this The subtitle makes me more confused rather than clarifying. Gun deaths and murders committed using firearms are not necessarily the same thing, so now I'm wondering where exactly the numbers are coming from. Now we'll get a little bit of practice in critiquing visualizations. Take a moment to gather your thoughts about this map, then I'll share mine. I think the choice of colors here is all wrong. By using the entire color spectrum, the shifts between hues looked abrupt. The end result is that my eye is drawn to the blue areas on the map. I don't think that that is what they were trying to emphasize, but that's the end result. 0% and 100% would look more similar than 0% and 50%. And I thought that this color scheme defied conventional color associations because the data that they're trying to convey is the percent of the population identifying as white, and their 0% is represented as red. When I'm thinking about concentrations of things, I think of a heat map, and I think of red as being the highest concentration, not the lowest concentration. Here's another one to look at. The colors don't add any new information to the visualization. We're only looking at two variables here: the name of the state, which is labeled, and population growth, which is shown in the length of the bars. The chosen colors are also very saturated, which can be hard to look at and to read. I think that this could be improved by choosing one less saturated color for all of the bars. And our last one. There are just too many different colors. It's almost impossible to go back and forth between the key and the chart to figure out which state is which. We could instead stick with about 6 colors to color code the dots by region of the US, rather than by individual state. Then we could label a few specifically selected dots on the map with their state name to draw attention to outliers or interesting cases. This week, you'll explore some data visualization blogs and galleries. Your assignment will be to add to our course data visualization Hall of Fame or Hall of Shame by posting a link to a visualization that caught your eye as being particularly good or particularly problematic on our discussion board. You'll describe the data relationship that's being represented, what techniques the creator used to express that relationship, and why you think those techniques were either effective or ineffective. Now, a Hall of Shame visualization doesn't need to be totally ineffective. It could just be one feature that you think the creator overlooked, or one decision that you think they should have made differently. You're welcome to use any visualization, blog, gallery, or site that you know of, but I've included a few suggestions in the discussion board activity in this module. Thank you for joining me for the Module 1 video. Please don't hesitate to contact me with any questions or comments. I look forward to seeing you on the discussion board.